Welcome back everyone to Infinite Math Help Squared. Today's video is about reflection. It's part 2 of transformations. The first one was involving translation, and then there was a prequel type video going over the applets, GeoGebra, and from Open Up Resources. Remember that for transformations, rotation, reflection, and translation are all types of rigid transformations. This means that they do not change in size or shape. So reflection, the figure should still look the same, but it will kind of look flipped or a mirror image of the original, which we call the pre-image. And this is in 2D space, right? So here's our first example. We have a pre-image of triangle EFG, and we're being told that we need to reflect it over the y-axis. Okay, when you reflect, you are creating a mirror image or a flipped version of the pre-image. And this means that each point should be equidistant from the line of reflection that we're asked to reflect over. So if we're being asked to reflect over the y-axis, the pre-image and the image, those points should be equidistant from the y-axis. Let's take F for example. F right now is 1 unit away from the y-axis. This means that F prime needs to be 1 unit away as well, but in the opposite direction, on the opposite side. E prime should follow the same rule. If E is only 1 unit away, then so must E prime. G prime, 1, 2, 3 units away, so 1, 2, 3 units away as well. And then sketch, close the figure, and here we have the image, E prime, F prime, G prime. It's reflected. I want to show you using the applet in case you're someone who was using it. So what you would like to do is make sure that you have your polygon graphed, your X and Y axis graphed, so that you have a point of reference, and if you have coordinates that you have to prove your work with, that you have that. You hit the reflection tool right here, click your polygon, and then click your axis, and then there you go. E prime, F prime, G prime. Let's take a quick peek at the coordinates, just in case someone needs to prove what they're doing. And let's see if you notice any patterns. Right now, G is at -1, -2, -3, comma, 1, 2, 3, E, and F. So F is at -1, comma, 1, 2, 3, 4, and E is at -1, comma, 2. Let's see what happened with the primes and see if we notice any pattern, because then you can write a rule and then you know every time you reflect over the y-axis what you have to do. G prime here is 1, 2, 3, and 1, 2, 3. F prime is +1, 1, 2, 3, 4. E prime, 1, comma, 2. So if you take a look from G to G prime, the only difference is that there used to be a negative on the X coordinate, but now there's not. How about from F? Ooh, let's undo that. I don't know why it's just like automatically clicks the eraser like that. Take a look at F, -1, 4. F prime is 1, comma, 4. This means, again, it lost a negative somehow. So the Y coordinate keeps staying the same, 3, 4, 2, 3, 4, 2. -3, 3, -1, 1, -1, 1, okay? So the x-coordinate is the opposite sign. It doesn't mean that it has to be positive. It just means it's the opposite sign of what it used to be. Good to know. If you reflect over the y-axis, you can keep your y-coordinates the same, but create the opposite sign of the x-coordinate, and voila, you're done. Okay, last example. This time we're going to reflect over a line, and we're going to reflect over the line y equals x. The polygon is a four-sided figure, polygon ABCD. Now, the same rule applies here. We're still going to create equidistant points. Let me label my pre-image and image. Here is my pre-image. And what's going to happen here is we're going to be creating 90-degree angles or perpendicular angles with the pre-image, the line y equals x, and the image. So what do I mean by this? Well, for example, let's take C for example. To get to the line y equals x, I'm going to go over 1, 2. But my reflective point will also be 2 away from y equals x. Remember, they have to be equidistant. But instead of being straight across because of the y equals x, or is slanted, it's at an angle, instead of just going straight up and down vertical like the y-axis, you would go 1, 2 up. Okay, and this would be our C prime. And you can see here that from the original to the new makes an L, which is a 90-degree angle or a perpendicular angle. So equidistant from y equals x, but in another direction. Okay, D is staying put. It's on the line, and if you reflect it over, it's basically reflecting over itself. So D is D prime. I'll label that D prime. And now let's take a look at B. If I go straight over to y equals x, I'm going 1, 2, 3, 4, which means from here it should be equidistant. 1, 2, 3, 4. This is where I will land. And this is B prime. A prime. 1, 2, 3, 1, 2, 3. Close your figure. Use a straight edge if you're using paper, please. This is so crooked. Okay. Let's take a look at a neater version in the applet. Here we go. They look like wings. I will walk you through. Oh. There we go. Scroll down to your translation, reflection, all that. Okay. I have my figure. I have my line. Make sure that you click reflect about a line. Click your polygon. Click your line. And voila. There it is. A lot neater than what my sketch was. The only thing left here is to actually note if there's a pattern here going reflecting over y equals x. So let's take a look at just one set. A is at 5, 2. A prime is at 2, 5. So what happened? X and y swapped places. I challenge you to examine B and B prime, C and C prime, D and D prime, and see if they still swap places. If they still swap places, you have a new pattern. You know that if you reflect over the line y equals x, all you have to do is simply swap the x and y coordinates. Okay, guys, part 3 will be rotations, and until next time.